Welcome to a new video. I am going to work through our Module 18 practice quiz for Algebra 1. So, Module 18 was all about multiplying polynomials, and in many of these problems we see the word product, which is also a clue that we should be multiplying. Number 1 says find the product of 7x cubed and 9x squared. Determine if each statement about the product is true or false. So it says find the product, and so that means that we need to multiply 7x cubed times 9x squared. And this problem is trickier if you don't actually sit here and multiply it out, because you might be confused about how we would know these things without multiplying them out. You don't. You need to think about multiplying them out or actually multiply them out. So A says, it is a binomial. Binomial is a word that means there are two terms, and there are not two terms here. There's only one. So this would be false. It is not a binomial. B says it has a coefficient of 63. The number in front of our x to the fifth is its coefficient. So this is true. It is 63 because we have to do 7 times 9 to get 63. And C says its degree is 6. Degree is the word for the exponent that the x has. And so since I got 5, because I've got x cubed and x squared, so x cubed and x squared, which together mean there are 5 x's, that would be false. It actually has a degree of 5, not 6. Number 2, find the product of 4xy and 9x minus 2y. So I'm taking 4xy and multiplying it with with 9x minus 2y. So what I need to do is use the distributive property and figure out what those will be. So for instance, 4 times 9 is 36. X times x gives us x squared. And then y doesn't have anything to match up with, so it stays y. Then I do 4xy times negative 2y, so that's a minus. And then 4 times 2, which is 8. X doesn't have anything to multiply with this time. And the y's can multiply together, which say y squared. Now, we've been making a big deal about putting things in standard form lately. This x squared y has a degree of 3, because when there's multiple letters, you add their exponents. And xy squared has a degree of 3 when you add the x and the y's exponents. And so these are just fine to leave in this order. You don't need to try to switch them around because they both have a degree of 3. Number 3. Trying to scroll up. No, I didn't really need to scroll up. Number 3, what is the product of 2x plus 7 times 2x minus 9? So this requires us to either use the distributive property or the FOIL acronym. So the distributive property is where we think I'm going to distribute 2x to both of these, and then I'm going to distribute 7 to both of these. Then the FOIL is the acronym first, outer, inner, last, and you end up doing the same thing no matter which way you think about it. So in either case, I'm going to do 2x times 2x, so first times first if you're thinking of FOIL, which is 4x squared. And then I'm going to do the 2x times the negative 9, because I'm distributing it to the second thing, or I'm doing the outer terms if I'm thinking about FOIL. So that's negative 18x. And then I'm going to do the inside term, 7 times 2x, which is 14x. And then I'm going to do the last term, 7 times negative 9, which is negative 63. Now, the vast majority of the time, not every single time, but so much of the time, when we FOIL or distributive property with a binomial times a binomial, the middle terms end up being like terms. So we want to do 4x squared minus negative 18x plus 14x is a negative 4x, and then the negative 63 stays negative 63. Just the middle terms were like terms, so the front term and the last term stay the same. Now, because the last thing we did, 18.3, is using special patterns, you might have said, well, shouldn't the middle terms cancel out? But that only works if these are the exact same terms with a plus and a minus. If it was 2x plus 7 and then 2x minus 7, yes, that would happen. But that's not what we have here. Number 4 is like a reverse multiple choice question. It looks like a regular multiple choice question, but it's actually like a reverse. It says, which product results in x squared minus 25? So, sorry, we need to think through these multiplication problems to see what gives us x squared minus 25. Unless, of course, we realize that this looks like that pattern that we have from 18.3, then we might be able to think of what the answer is more quickly. So if we want to do it the long way, we'd have to say, let me distribute this x, so x squared, and then it would be negative 5x. Well, that doesn't work, so that's not it. X minus 5 squared, and this is actually a special pattern as well. If you don't know the pattern, we have to write it twice and multiply it out. The pattern is that it's the first thing squared, and then it's the second thing squared, but in the middle we do x times 5, which is 5x, and then we double it. Because it's a minus sign, we'd have a minus sign. Well, that doesn't match up, and I could have gotten there probably faster. Like, I could have stopped when I had plus 25. C, this is the correct pattern to get x squared minus 25, that you do x times x and get x squared, and then you do the outside terms, negative 5x, and then the inside terms, positive 5x, and then 5 times negative 5 is negative 25, and these cancel out in the middle, and so this is the correct answer. So this problem is much, much, much quicker if you do understand the relationship with those patterns, but if you don't, you can just go through and multiply them and see which one matches up. Number 5, speaking of those special patterns, this refers to one of those patterns, perfect square trinomials. So you end up with a perfect square trinomials if the following things are true. That the first thing you have is something squared, and the last thing you have could be written as something squared. And in the middle here, right here, you have this thing and this thing together, but doubled. And that sounds really weird and kind of complicated, but let's look at an example. If I think about x squared plus 8x plus 16, and I'm trying to figure out if this is a perfect square trinomial, I need to think, is this something squared? Well, yes, it's x squared. Is this something squared? Yes, it's 4 squared. Is the middle these two things combined but doubled? So x and 4 together, but then doubled, which would be 8x. Yes, it is. So this is a perfect square trinomial. So let's look at the next one, x squared plus 2x plus 2. So is this something squared? Yes. Is this something squared? No. 2 is not a perfect square. So x squared plus 2x plus 2 does not work. And then C. So we're going to do the same thing. I'm just going to write over here. So is x squared something squared? Yes. Is 49 something squared? Yes. If I put those together and then double it, do I get the middle term? Yes, because 7x doubled is 14x. And then this last one, is x squared something squared? Yes. Is 100 something squared? Yes. If I put these together and then double it, do I get the middle term? Yes. This next one on number 6, we are using the distributive property because we have too many terms to FOIL. So we're going to do x times all 3 of these things. That's going to give us 3 terms. And then we're going to do negative 4 times each of these, and that's going to give us 3 more terms for a total of 6. And then we're going to add things together that are like terms. So I'm going to do x times 2x squared, which is 2x cubed. And then I'm going to do x times 9x, which is 9x squared. And then I'm going to do x times negative 10, which is negative 10x. Then I am going to do the same thing, but with the negative 4. So negative 4 times 2x squared is negative 8x squared. Negative 4 times 9x is negative 36x. Negative 4 times negative 10 is plus 40. So I'm going to add, the way I wrote this down with the second one below the first one is I lined up my like terms to make it easier to see. Didn't really leave myself enough room here, so I'll just write it right here. The 2x cubed doesn't have anything to add with. 9x squared minus x squared is plus x squared. Negative 10x minus 36x is negative 46x, and then the plus 40 doesn't have anything to add with, so that is my answer. And finally, I'm going to multiply x minus 9 squared. If you know the pattern, then you don't have to show any work. But if you don't know the pattern, what you want to do is make sure you do x minus 9 written twice in FOIL or distributive property, because if you just look at x minus 9 squared, you might think that this is x squared plus 81 or minus 81, and that would not be the whole story. It is x squared and it is plus 81, but there is a middle term that comes from doing the x times the negative 9 here and the x times the negative 9 here and adding them together. So you'd get negative 9x and then another negative 9x, which together makes negative 18x. This is how we get the things on number 5, the perfect square trinomials, is by having a situation like this where we're squaring a binomial. So that would be our answer, and that would be an example, another example of a perfect square trinomial. So this is our Module 18 practice quiz. Happy studying!